We are very sorry for the inconvenience. When we have advantages of technology, we have disadvantages of technology. So, Swati ma'am is back with us, and you can proceed with your lecture. Thank you so much.
Thank you so much and sorry for the inconvenience. Um, Please share the PPT if possible.
Ma'am, you can carry on with the lecture. We are just sharing the
Okay,
PPT.
okay, okay. Thank you so much. So my topic for today's lecture, that is FDP, is statistical techniques in research. So I'm going to give you a brief, overview of various statistical techniques which are used in research. We are going to discuss about the various, bases on which you can select an appropriate technique for your research. Starting with the statistical method introduction is when we talk about the statistical methods are basically talking about the how we are going to plan, how we are going to design, how we are going to collect the data, analyze it, draw meaningful interpretation out of that particular data that we have collected, and then reporting the whatever research findings we have gathered or interpreted. So the results and inferences will be precise, they will be accurate only if we have a proper statistical tool which will be used in the research process. So, selection of an appropriate statistical method, we have to understand what are the various assumptions, what are the different conditions of using a statistical method. So, our selection of an appropriate method will be depending upon various assumption, various conditions. Now we are going to discuss about various factors influencing the selection of statistical methods. When we are saying that I have to use a particular statistical method in my research, how will I take that decision? So there are various factors that can influence that decision. First of all, the first thing we have to keep in mind is the aim or the objective of the study. What are you trying to do from a particular study? Am I going to study the relationship between the two variable? Am I going to study the effect of one variable on another variable? So I have to first of all decide the aim and objective of the study. That aim and objective of the study will give me one direction on selection of a statistical method. Second can be the type of variables. How many type of variables are there? Is there one variable in the study, or there are two variables, or there are more than two variables? That will also affect the selection of the statistical method. Third could be the type of distribution of the data we are using. Type of distribution is whether your data is normally distributed or it is not normally distributed. That is going to decide what kind of statistical tool or method you are going to use in your research. Next could be the observation, the respondents, the people you are studying, whether those observations are related to each other, are those, variables paired or unpaired. That is also going to affect your selection of statistical method. Before starting the before giving you the overview about the statistical method that could be used in research, we have to create a base. So you must understand certain things like what are the variables, what are the kind of statistics that can be used in research. So I'm going to start with the variables. So because our study is always based on the variables, so you have to understand what is a variable. When we are talking about variable is basically a characteristics that varies from one individual member of a particular population that you are going to study to another individual of that particular population. That is why it is known as variable. For example, we are taking the example of height and weight because they are measured on a particular type of scale. So when we are measuring a particular variable which have some quantitative information, we can say that that particular variable is a quantitative variable. On the other hand, when we are saying that a characteristics that cannot be quantified, that will be a qualitative variable. For example, I'm saying a gender, which can be categorized into male or female. So that is basically showing the quality of a person. So that is an example of qualitative variable. So we have to differentiate when we are starting with the statistical techniques. We have to differentiate our variable on the basis of this category. That is whether your variable is quantitative in term or quantitative in nature, or your variable is qualitative in nature. Then we have classification of variable. Talking about the classification of the variable, generally the variable is categorized as qualitative and quantitative, and then we have further categorization, which is ordinal, discrete, continuous. When we talk about the ordinal variable lies in both the category qualitative as well as quantitative. For example, I'm saying that we have the category of gender, that is a kind of nominal variable which have two categories. When we categorize gender into male or female, that is a qualitative aspect. When we assign certain quantitative factor, for example, for my analysis purpose, I'm assigning a value of 1 to male and 0 for female. So that is how I'm converting my nominal data or qualitative data into quantitative data. So this can be possible. Then we have the, can you move forward with the slide? Now I'm going to discuss about various kind of variable, like discrete variable. Discrete is something which is in whole number. For example, I'm saying discrete variable could be number of respondent in a study. Discrete variable can be the scores which student have achieved in their class test or in their exams. So discrete numerical data can be recorded in whole numbers. Okay. Then we are talking about the nominal variable. Nominal variable is something which is categorical in nature. The data can be classified into categories and it can be arranged in any way. There need not be any order in that. For example, I've already explained gender is a category, male and female, and it is a kind of binary or dichotomous data. Then talking about the ordinal variable is different from nominal variable in one sense that it has order in it. So if I'm talking about the socio-economic classification, someone is wealthy, someone is middle, they lie in the middle income group, and someone is poor. So basically the data is converted into order where the person belonging to high income group is at first, then we have middle income group, and then we have people belonging to poor category. Okay, next. Then we have interval variables and ratio scales. Interval variable and ratio scales are basically the continuous variable. Interval variable are similar to ordinal, but here the interval between the value is equal. So if I'm taking an example of temperature, so temperature, if it is starting from 0, then 10, 20, 30. So this is basically the difference between the two interval is same. The most important thing in which differentiate interval and ratio scale is here in interval scale, the 0 does not mean absence of the variable. For example, in Likert scale, we have a 5-point Likert scale where we assign a value of 0 to the neutral. So neutral doesn't mean that it is an absence of variable. We can say the person is neutral. He cannot say anything. This example can also, attach itself in temperature. For example, we are saying that there is 0 degree temperature. It doesn't mean the temperature is absent. We can say the temperature is 0. Coming to the next point, that is ratio scale. The ratio scale is also similar to the interval scale. The equal difference between the scale is also available in the ratio scale. The main difference between the intervals variable or interval scale and the ratio scale is the 0 ratio scale, the absence or zero means the absence of variable. For example, we are measuring the weight. So zero weight means there is no weight. If we are saying the sales are zero, means sales are zero, there is no sale in a particular year. So this is the basic difference between when we differentiate between interval scale and the ratio scale. Next, please. That is all about, first of all, when you are doing research, you have to understand the various kind of variables, because on the basis of this classification, your statistical tools will vary. You cannot, you have to decide whether your variable is categorical in nature, whether your variable is continuous in nature, it is on ratio scale or interval scales. This will be the main important base for selecting your statistical tool. Now, talking about the next concept, which is very important while selecting your statistical tool, is differentiation, or differentiation on the basis of parametric and non-parametric methods. Now, talking about the parametric statistics or non-parametric statistics, parametric statistics is basically based on the assumptions. Before applying the parametric tools, you have to fulfill certain assumptions. Um, the parametric tools or statistics is all based on the concept of mean. The main assumption for the parametric tool to be applied is normal distribution. Your data should be normally distributed before deciding whether you can apply the parametric statistics or not. Then the type of data. If you want to apply the parametric statistics, your data has to be continuous or interval scale or ratio scale. Okay. Now, talking about the non-parametric statistics, when we are talking about the non-parametric statistics, basically these type of statistics do not follow any kind of assumption. So we can say if these certain assumptions like normal distribution assumption is not met, then you can apply the non-parametric statistics alternative, which is available to us. Okay. Then we have, because there is no normal distribution, sorry, back slide, please. Previous slide. Yes. This particular non-parametric statistics is based on the concept of median, and the non-parametric statistics will only be followed when there is the distribution is not normally distributed. And in this type of statistics, the type of data can be nominal or ordinal. Next slide, please. Now, this particular slide is given, this is basically describing what kind of, type of test you can apply, or you can decide whether your data is parametric, sorry, your statistics is parametric or non-parametric. So if you have descriptive statistics, in that case, parametric methods available to us are mean. You can apply standard deviation. But in case of non-parametric method, we can use median, interquartile range. Next is sample with population or hypothetical value when we have a single variable. Then in that case, in parametric method, we have one sample t-test. In non-parametric test, we have one sample Wilcoxon signed rank test. So these are basically, if we have the option of one sample t-test, its alternative in non-parametric test is one sample Wilcoxon signed rank test. If you have two unpaired groups, in that case, you can use independent sample t-test, whereas its alternative available in non-parametric method is Mann-Whitney U-test. Next is two paired group test, where the groups are paired to each other, that I'm going to discuss in the next slides. What is unpaired group, what is paired group. In paired group, we have the option of paired sample t-test, and in non-parametric method, we have related sample Wilcoxon signed test. So this is the basically table that is giving you the information about the description, the type of your objective you want to achieve, and then we have the decision whether you can use parametric method, or you have the alternative of using non-parametric method. In last, if you want to predict a variable, or you want to find out the impact of one variable over the other variable, you can use a parametric method, that is linear regression. Whereas on the other hand, non-parametric method, we have the option of non-linear regression or log linear regression. Okay. Next slide, please. Now we are going to talk about the type of statistical techniques we have, that is descriptive statistics and inferential statistics. Next. Now, talking about the descriptive techniques which are available to us, descriptive statistics is just giving you the summary of the population, where whether we have when we have collected the data and we want to summarize that information. In that case, we have the option of descriptive techniques. It will provide you the summarized information of the characteristics of the distribution of the values in the data set, how your data set is dispersed, how its distribution is. So in order to give a quick glance, in order to understand, you can go for the central tendencies. For example, you can use the mean median mode concept, and you can understand your distribution, because that distribution, whether your data is normally distributed or not normally distributed, that is very important in research. So that is possible through descriptive techniques. Next slide. Now, talking about the main descriptive statistics that we can use is the mean, median, mode. They are the common, measures of central tendency. Measures of dispersion could be maximum or minimum value range. You can have standard deviation. You can have variance. How your distribution is. Is it normally distributed? Is it skewed? It is positively skewed, negatively skewed. So you have to understand the distribution. For example, we can take an example. We are taking the scores of the student for a particular year. So the best way to summarize that data is you can use the mean, you can use the standard deviation and know how much variation in the school scores of the student. You can use the concept of frequencies, you can use the concept of percentages. So basically, this descriptive statistics is helping you to understand the data well and in quickest way. So you can use the graphs also. Next slide, please. Now we are talking about the inferential statistics, because mostly the first half is our descriptive statistics and next half is our inferential statistics, because inferential statistics will tell you how, or various out of various analytical tool, you are going to draw the inferences about the population. Because we cannot study the whole population, we have to take a sample out of the population and then we have to draw the inferences, what was the results. So sample chosen in a particular inferential statistics has to be representative of the entire population. There are number of statistical techniques available in the research through which you can select a sample which will be the best representative of your entire population. So here the main objective of when we are talking about the inferential statistic, the main objective here is to make generalization about a particular population. That is only possible if you are able to select a sample which is representative of the whole or entire population. Next slide, please. So, when we are talking about the inferential statistics, the purpose is to answer or test the hypothesis. Hypotheses are basically the assumption about the condition, assumption about a particular situation. So, there can be two type of hypotheses that can be created. Null hypothesis, which states basically that there is no significant relationship or there is no significant difference between the population variables that have been included in the research question. So there are a number of inferential statistics that can be applied, like t-test, z-test, linear regression. These are basically the analytical tools which are used for making the inferences. Next step. Now when we are talking about the inferential statistics and we have to accept or reject a particular hypothesis, this p value is very important. P value is basically the probability of happening of an event which has occurred by chance. So p value, whenever we are running a test, we have to find out the significance value or p value and then give the inferences whether to accept a null hypothesis or reject it. So when we are talking about the p value, because it is a probability value, its value will lie between 0 and 1, and it will be interpreted by a particular researcher and decide whether they can accept a particular null hypothesis or they have to reject it. So if the p value is less than 0.05, the result will be highly significant, and you have to reject the null hypothesis and accept the alternative hypothesis and state that there is a significant difference or there is a significant impact of one variable on the other variable. Next. So this is the basically the base for deciding the statistical tools in research and data analysis, where we decide about the variables, what kind of variables are there in the study. Then we have to decide about whether your data, what is the distribution of your data, because on the basis of that you will decide whether you can use the parametric techniques or you can use the non-parametric techniques. Now we are going to study or discuss about the statistical tools which can be used in research and data analysis. Next, first of all, our type of statistical tool will be depending upon number of variables in the study. How many number of variables are there in the study? We have univariate variables, we have bivariate variables, we have multivariate variables. Univariate means single variable. Bivariate means there are two variables, and multivariate means there are more than two variables in the study. Next. First of all, I'll be talking about the univariate variables. In univariate variables, we have measures of central tendency, means I can use mean, I can use median, I can use mode to give the descriptive statistics of a particular variables that have been used in the study. Then we have the option of one sample t-test. Next slide, please. Now, this is just the overview of what do you mean by mean. We mean arithmetical average, that is sum of all the scores divided by the number of scores. Mean is basically when we are calculating the mean is very important for parametric statistical tools. Mean is very important when we are deciding the distribution. We are drawing the distribution, whether the distribution normally distributed or not. So our mean is basically influenced by various extreme variables which are known as outliers. If there are many outliers in your study, there are many extreme values in your study, that is surely going to influence, that is, it is surely going to negatively influence your results. Next. Then we have the concept of median. We know median is the middle of a distribution. When we are talking about the median is basically based on ranked data. The whole data will be ranked, and median will be dividing that ranked data in two halves. One half where the variable in the sample is above, and other will be below the median value. Then we have the concept of variance. Now this concept of variance is also important because we want to know how dispersed or how spread out is our distribution when we are calculating or when we are drawing a normal distribution curve, and we need to know how closely an individual observation is clustering near a particular mean variable. From this variance, we can also calculate the standard deviation, which is just the square of this variance value. Standard deviation is very important when we are talking about the calculating the mean, because it will show you how dispersed your data is from the mean value. Next slide, please. Next. Now, talking about this was all about the measures of central tendency that can be used as a descriptive statistical tools. Then we have the concept of one sample t-test. One sample t-test is basically you will be able to determine whether an unknown population mean is different from a specific value or not. For example, one sample t-test means it will be applicable only on one variable or one sample. For example, an airport company, they want to test the battery performance. For example, they have said that this particular airport will work for 10 hours. That means their battery performance is all for 10 hours. Now they want to study whether this particular claim is true or not. So if they want to study, they can select a sample out of the various population or various airports that they are manufacturing. They can take a sample, they can conduct a particular study on that particular sample, and then decide whether their population mean is different from the value that they have specified or not. So if their value is close to the specified value, they can say that there is no significant difference between the means of two populations that we are going to study. Next, please. So this is the simplest method of one's sample t-test. Now we are going to discuss about the bivariate variables. Bivariate variables are basically the variables where there are two variables. So two variables, when there are two variables, then we have to decide whether we can apply parametric test or we can apply non-parametric test. First is independent t-test in under the categorization of parametric test. Then we have paired sample t-test. Then we have correlation, regression. In non-parametric test, we have Mann-Whitney U-test, Wilcoxon signed rank test, and then we have chi-square test. Next, please. The first test under the parametric, statistical tools that we are going to test is the t-test. This is the most common method that we use in every area, whether it is science, you can say pharmaceutical sciences, in sciences, management. This particular test is commonly used because this particular method will evaluate the difference in means between the two groups. When we are saying difference in means, we can say, as we have already discussed, that whenever we are using the parametric test, they will be based on the mean value. So here the aim is to evaluate difference in means between the two groups. When we are saying two group means, here we have two different groups. For example, a t-test can be used to test for a significance difference in test scores between the group of patients who were given a drug and a control group who were not given any kind of treatment. For example, we are considering here two groups of patients. One group of patients are given certain intervention, you can say they are given certain drug, and other is the control group who are not given any kind of treatment, and they wanted to test whether their test scores are different or same. So here the two groups that we have created, we can gather information uh, of various tests. We can gather information on the test of these two kind of patients that we have included in our study, and then we can run this particular t-test. When we are talking about the t-test is generally applicable when the sample size is very small, that is the sample size is less than 30. When your sample size is greater than 30, the test will be known as Z test. The whole procedure will be same, but the test will be known as Z test because this will be working only when the sample size is large. Okay. Next slide, please. Now, because we have already mentioned that in parametric, when you have to apply certain parametric techniques, certain assumptions have to be fulfilled. So, if you want to apply t-test, in that case, the sample should be normally distributed. First condition has to be fulfilled. Second is sample must be representative of the population so that we can make generalization of the inferences at the end of the analysis. Third assumption is the equal variances are assumed when two independent samples are used to test the hypothesis. This equal variances in two independent sample means if you are taking two samples from a population, their characteristics should not differ much. Okay, so we have to make sure the variance for a particular set of independent sample group, the variance should not be much different for from each other. And last is when you have to apply a t-test, you have to make sure that variable must be either interval or ratio scale. So you can say you cannot apply t-test on ordinal or nominal category kind of variables. Next, please. Okay. That was all about the t-test. T-test can be applied only when we have independent groups. Independent group, I mean that if we are taking a set of respondent in one group, they cannot be included in other group. For example, the best example for this independent group is public and private sector banks. So if there are public sector bank, they cannot be included in private sector bank. If they are private sector bank, they cannot be included in private sector. So the group should be individual, they should be independent from each other. Now talking about the pair t-test. Pair t-test is also known as dependent t-test, where we can say when we are comparing the two groups, the group will be the same, but we'll be conducting a pre-study and post-study. For example, we have one group with pre-test and post-test. For example, a teacher wants to examine the effect of new set of e-learning platform on students' achievement. So here we can test the student before the beginning of the year. That will be known as pre-test. And then we'll be conducting a test after giving them exposure to a new set of e-learning platform and then scoring them. And then we'll be comparing these two scores. This will be known as pair t-test. So pair t-test is possible when you are taking one group only, but you want to give them exposure to a particular training program. For example, you can take an example of employees. For example, a company is giving a particular training to their employees. So you can conduct a pre-test before giving them a particular kind of training, and then take a test after providing a kind of training, and then compare their scores. So this is basically this pair t-test will be possible, advantages or beneficial in a situation where you want to compare pre and post score of a particular variable in the study. Next slide, please. Now I'm going to discuss about the non-parametric alternatives to the two tests that I've already discussed, that is independent t-test and pair t-test. When I was talking about the independent t-test, for example, your normal distribution is assumption is not fulfilled. Your data is not normally distributed. In that case, you have an alternative to the independent t-test. That is, you can use Mann-Whitney u-test there. Okay, so you have to take into consideration only one thing, that is fulfillment of the normal distribution assumption. If it is fulfilled, you can use t-test. If it is not fulfilled, then you have the alternative of Mann-Whitney u-test. So Mann-Whitney u-test जो है, that will be basically used to compare the differences between the two independent group, where one dependent variable is either ordinal or continuous, but they are not normal distribute. Next slide, please. I'm going to take an example of describing how Mann-Whitney U-test will be functioning. Mann-Whitney U-test, it can be used to understand whether the salaries which are measured on continuous scales means ratio scale, differ based on the educational level. So here the most important dependent variable is your salaries, which is continuous in nature, and you have to find out whether the salaries differ among the people who have different educational level. So that educational level can be categorized in two groups, that is people who have graduated or gone to university or who were in school. So there have been two categories. First category, high school category. Second category is university category. So we have created two independent groups. Now we want to see that whether these two groups are differ or they are similar on the basis of salaries they are getting. So in this case, you can use the Mann-Whitney U-test as an alternative to independent t-test. Next slide, please. Now, this is the second type of alternative to the paired t-test that we have already discussed. Wilcoxon rank sum test is an alternative to the paired t-test. Here also you have to identify whether your data is normally distributed or not. If the data is not normally distributed and you want to compare two paired tests or paired samples, then they have the option of using the Wilcoxon rank sum test. Okay. Now, here the assumption is when we are talking about testing a hypothesis, you have one null hypothesis which will be stating that there is no significant difference between the two population or between the two variable among this particular sample. Okay. Next slide, please. For example, a business, they want to use this technique to understand whether there was difference in manager's salary before or after taking a PhD programs. So they want to study whether there is a difference between the salaries of the manager before or after undertaking a PhD program. So in that case, in this particular example, the variable that they are studying is the salaries, and that salary is a metric variable, or you can say it is continuous or ratio scale, and two related group is the managers, and we are taking these two related groups at two different point of time, that is before the completion of PhD and after the completion of PhD. So this is the most important example that can be associated with this particular method. We can also take a one more example that is related to marketing. A company wants to study that have the sales increased following a particular advertisement campaign. So we can take the sales um, as a variable, and we can have a data which is before the particular campaign was used, and after the sales, after the campaign sales values we can take up, and then we can compare whether the sales have increased or decreased. So in that case also, but you have to just follow the criteria that your data, when you are using this Wilcoxon technique, your data should not be normally distributed, and it is an alternative to paired t-test. Next slide, please. Now I'm focusing on the multivariate technique because it is the most important technique, and in recent research, mostly people focus on the multivariate techniques because generally there are not only two variables, there are more variables which are included in a particular study. So in that multivariate technique also, we have parametric and non-parametric classification. In parametric classification, we have the concept of ANOVA. We have the concept of multiple regression, logistic regression, factor analysis, non-parametric test. In classification of non-parametric test, we have Kruskal-Wallis test. So I'm going to cover some of these tests because describing them will take a lot of time. So I have taken some important techniques that I'm going to discuss in detail. Next slide, please. So first, we are going to talk about the ANOVA method. ANOVA method is, when we talked about the independent t-test, where we have two groups and we were making comparison between the means of those two groups. ANOVA comes in the picture when we say that there are more than two sample groups. So, in order to examine the significance of difference among more than two sample groups, you can apply this ANOVA technique. For example, um, we want to assess the effectiveness of four different programs on the income group of the people or income group that we have created. So basically, we have four different programs or four different sample groups which are available to us. So because the variables or sample groups are more than two, we can apply ANOVA here. Then this ANOVA is basically further divided into two parts, that is one way ANOVA and two way ANOVA. One way ANOVA is basically when we have only one factor, and on the basis of that one factor, we want to test the significance of difference. For example, we have taken two examples here. First is there are different students from different schools who have taken a same exam. We want to study that if the difference, or if one college performs better than other, or one college outperforms the other college. So we have different categories, or we have different groups, and we want to study whether there is a significant difference among these groups or not. Second example we can take here is, I want to study the effect of consumption of tea on weight loss. For that, we have one continuous variable here is the weight loss, and the categorization of tea is more than two sample groups, because we have here three groups. First is green tea, then we have black tea, or we have no tea. So the main thing that you have to understand before applying ANOVA, that you have to see how many categories or how many sample groups we have. If there are two sample groups, you can go for independent t-test. If there are more than two sample group, three sample groups we have in our study, in that case you can go for ANOVA. But your dependent variable, for example here is the weight loss, that has to be continuous in nature. Okay, next slide please. Now, I've given you the example of one factor. We have also the example of two factor ANOVA, means we are using two factor one at a time or at the same time. For example, you might want to find out whether there is an interaction between income and gender for anxiety level at job interviews. So, first of all, in previous question, we only had one category, that is the impact of different type of teas on your weight loss. Now we have two categories, that is income and gender, and the dependent variable is anxiety level at job interviews. Okay. Then in this particular question, your outcome variable or your dependent variable is anxiety level, and the other variables are gender and income, and these two or these both variables are categorical in nature. So gender can be categorized into male female, income will be ordinal, where we will be having three levels of income, 0 to 1 lakh, 1 lakh to 2 lakh, 2 lakh to 3 lakh. So we'll be categorizing the income as well. So here also ANOVA also work on the basis of mean, and here also we want to test the hypothesis. We will be creating an hypothesis. We will reject the hypothesis of null hypothesis of no difference between means, and will accept the alternate hypothesis that mean are different if your p value is less than 0.05. Okay, So this is basically, you have to understand the concept, when you can apply the concept or tool of ANOVA, and how will you differentiate between one way ANOVA and two way ANOVA. Next slide, please. Now, the next topic that is Kruskal-Wallis test. Kruskal-Wallis test is a non-parametric alternative of ANOVA test. So that we have already discussed, that if you are considering distribution, if your distribution is not normally distributed and you want to compare more than two groups, then an alternative is available to you, that is Kruskal-Wallis test. In that case, you will use this particular test, and it is also sometimes known as one way ANOVA on ranks. Why rank? Because when we are talking about the non-parametric test always work on the concept of rank. If you have given certain data and you are using, for example, you are using SPSS for data analysis, that will convert your data into ranks, and then whole basis will be the rank system. So Kruskal-Wallis test, you will be forming an hypothesis that if there is significant difference between, if there is any significant difference between the various groups which are included under the study. Next slide, please. For example, you want to find out how socioeconomic status affect the attitude towards the sales tax increase. For example, the government have increased the sales tax, and now you want to know how this is being affected by the social economic status. So your independent variable will be the socioeconomic status, with three levels of socioeconomic status. We, for example, we have a working class, then we have a middle class, and then we have wealthy or rich class. Now, dependent variable is being measured on the you can say 5-point Likert scale, because we are going to study the attitude, because attitude is a kind of variable that we cannot study directly. So in that case, you have to frame a questionnaire, you have to ask question on a 5-point Likert scale, which will be having statements, and the people have to agree or disagree or to a particular statement. So in that case, the same example can be used in ANOVA also, but you have to find out whether your data is normally distributed or not. So you can say, if the data is not normally distributed, you have an alternative of using Kruskal-Wallis test as an alternative to ANOVA. Next slide, please. Now, chi-square test is also very important non-parametric test. Generally, there are two you can say objective of running a chi-square test. Chi-square test can be used for testing the independence, and as well as also for checking the goodness of the fit. Whenever you are fitting a model, for example, you are running a regression test and you want to find out the goodness of a fit, whether your model is fit or not. In that case, chi-square test can be used for testing the goodness of the fit of a particular model. But here I am including the test of independence. Independence means we want to determine that we have two variables, and both of the variables are categorical in nature. Categorical in nature, either your variable is nominal or categorical or ordinal in nature. And in that case, you want to find out the association between those two variables. So whether your variable is independent or whether your variable is related, that can be tested through the use of chi-square test of independence. So you can say, if your both variables, means your independent variable as well as your dependent variable, both are in categorical form, then you can use the chi-square test of independence to determine whether there is a relation between these two variables or not. So basically, when we are talking about the chi-square test data is basically displayed in contingency table. It will be in the form of table because we have two categories. For example, we have gender category and we have income category. So in that case, a table will be formulated, and the on the basis of that table, you will be able to analyze and run the chi-square test and find out whether there is any relationship between the two variables or not. Next slide, please. For example, a researcher wants to study, or they want to conduct a study to examine the relationship between the gender and empathy. So you can see both the variables, gender and empathy, are categorical nature, where gender has two category, male and female. Empathy also has two category, high empathy or low empathy. So basically, your this particular data can be converted into a table, and then chi-square basically works on the expected and observed values, and then they will be giving you the analysis result, and on the basis of which we can interpret whether you have to accept or reject, or whether you have to accept or reject the particular hypothesis. For example, next sample can be, you want to find out the association between the gender and academic performance, male or female, and we want to understand whether they have relationship with the academic performance or not. Third can be where a company wants to determine whether there is a relationship between the type of product you have purchased and the customer location. So, whether there is an association between the people belonging to a particular location, for example, I create two location, urban and rural. In that case, I want to associate this particular variable with the type of product they are purchasing. Okay. So chi-square test of independence can be used for the purpose of stating, or for the purpose of understanding the relationship between the two variable, whether there is a relationship or not, or association two variables or not. Next slide, please. Now, the most important analysis that is used in statistics, or the statistical tool that is used in research, is the regression analysis. I'm going to talk about the two type of regression analysis, how we differentiate between these two type of regression analysis. We have to understand the concept of dependent variable and independent variable. Dependent variable or independent variable is whose effect I'm checking on the dependent variable. So selecting the type of regression analysis, we have two type of regression analysis: multiple regression and logistic regression. For example, I'm using multiple regression. The type of dependent variable should be continuous or in ratio scale. When I'm deciding the type of independent variable, that has to be numerical. Numerical is basically your ordinal, ratio scale, interval scale. Okay. So in that case, if you are selecting multiple regression, these two criteria should be fulfilled. Means your dependent variable should be continuous or ratio scale, and your independent variable should be numerical. On the other hand, when we are talking about the logistic regression, the main difference between multiple and logistic regression is the type of dependent variable. So, type of dependent variable in logistic regression is generally categorical in nature. Okay, and type of independent variable could be numeric. So, you have to first identify the dependent variable. If it is continuous, you can apply multiple regression. If it is categorical, then you have to go for the other technique, that is logistic regression. Next slide, please. Now, talking about the regression analysis basically deals with estimating the value of dependent variable on the basis of one or more independent variable. So generally, if the objective of your study is to check or study the effect of one variable over the other variable, in that case, you can apply regression analysis. Before applying regression analysis, you have to assume that there is a linear relationship between the dependent variable and independent variable. Then we have an error term. Error term is basically the variation which is not explained in the, or which it represent the unexplained variation in the dependent variable. It works on the least square method. Regression is used to examine the effect of some specific factor while taking into account the other factors that can influence that particular outcome or that dependent variable. Next slide, please. Now, regression analysis, when we are talking about regression analysis, the regression equation will look like this, where y is equal to alpha plus beta xi plus e. Y represents the dependent variable, x represented the independent variables, and alpha, that intercept where this particular variable alpha will mean that what will be the value of y when x is equal to 0, and e term represents the error term, the unexplained variation in the dependent variable. Next slide. Basically, regression analysis will be used either for studying the impact, prediction, hypothesis testing. So in that case, you can use the multiple regression concept. In multiple regression, there are more than one independent variable in the model. Linear regression, when we have only one variable, one independent variable, one dependent variable. Multiple regression, when there are more than one independent variable. So multiple regression, in this particular multiple regression, the researcher wants to examine the effect of many factors on a particular outcome or dependent variable at a same time. Okay. So the particular regression equation will vary some, where all the parameters will be included in this particular regression equation, where y will be the same dependent variable, x1 x2 will be the parameters, b0 will be the interceptor, and beta 1 beta 2, or sorry, b1 and b2 will be referred as the regression coefficient. These will be the value on the basis of will you will be doing the interpretation. Okay, I'll be discussing this in the later slide, how you interpret the results of the multiple regression. Next slide, please. Now, talking about the assumptions in regression. When we are applying the regression analysis, we have to understand about the assumption, because regression analysis is a parametric technique, and before applying the parametric technique, we have to understand whether the assumptions of regression analysis are fulfilled or not. Okay, the first assumption in regression analysis is that your dependent variable should be measured on continuous scale, either interval or ratio, that I've already discussed through the chart. So your variable, dependent variable, has to be interval or ratio scale. Then you have two or more independent variables. They can be continuous, they can be categorical. In general, we say the independent variable can be numeric in nature. Third is regression model is linear in nature. Linear regression model means that there has to be a linear relationship between the independent variable and the dependent variable. So this can be done by using a scattered plot. You can enter the values of independent variable, you can enter the dependent variable values, and you can see the scattered plot chart, or you can check through the visual graphical display and understand whether your data is linearly related to your dependent variable or not. Okay, next slide, please. Sorry, no multicollinearity. When we are talking about the no multicollinearity means that your variable, that independent variable we have included in the study, should not be should not have any correlation with each other. So multicollinearity, because if there is any kind of multicollinearity, if the independent variables are related to each other, you will not be able to understand the real effect of a particular variable on the dependent variable. Fifth is residual error terms in estimating the dependent variable. They have to be normally distributed. When we talk about the normal distribution of a particular variable in regression analysis, we do not check the normal distribution of the variable, we check the normal distribution of the residual error terms. That is, we have already discussed in the equation, that is E term, which is the residual error of a particular regression equation, which is unexplained by in the dependent variable. Okay, so residual error term which are used in estimating the dependent variable has to be normally distributed. We have studentized, value, predicted value, which is calculated in the regression equation only. We will be using that particular value to use it in the pp plots. We can draw normal probability curve and find out whether our residual error terms are normally distributed or not. Then we have also the concept or assumption of residual error distribution in predicting the dependent variable. Means your error term should not be related to each other. That is also very important, which is known as homoscedasticity. Next slide, please. So these are basically six assumptions which has to be fulfilled with before applying the regression equation. Next slide. Then how to make interpretation of the analysis result which are received through any statistical tool you are using. So regression analysis, we have for example, we have a slope, that is our beta value is 2. That 2 value will be depicting, for example, 1 unit increase your independent variable will have a 2 unit increase in your dependent variable. So whenever you have the results will be shown in the form of tables where we'll be having a descriptive statistics, we'll be having an ANOVA table, we'll be having a table which will be showing us the beta coefficient, standardized, unstandardized beta coefficient, their significance value, and on the basis of that, you'll be judging whether the particular independent variable has an effect on dependent variable or not. Next slide, please. And next we have the R square value. R square value is basically the coefficient of determination where we can say whether your model is, what is the quality of the model, whether your model is fit or not. That can be determined by the R square value. R square value is generally seen when you only have one, independent variable in your equation. When you have more than one independent variable in your equation, or you can say when you are running multiple regression analysis, in that case you have to focus on the adjusted R square, which adjusts for the number of independent variables which you have included in the model. So adjusted R square, your R square will be adjusted according to the number of variables which you have included in the study. Then we have also the F statistic test. We will be that will be showing that will be showing the test for the joint significance of all the parameters in the models that we have included. So next slide, please. I'm going to discuss about how the results look like in a particular regression analysis. For example, you want to study the impact of credit risk, operational efficiency, and asset management plus bank size on ROE. So I'm just taking two, three independent variables. The effect of credit risk, operational efficiency, bank size on the dependent variable, that is ROA, return on assets. Okay. Next. So this will be your model summary, which will be providing you the information related to R square, adjusted R square, and standard error. This R square should have been 0.885. This is by mistake 0.085. This R square is basically showing the correlation between the variable. Okay. R square is the important because this will be showing how much variation is done by the independent variable in the dependent variable, and adjusted R square will be used in the multiple regression equation. So we can say adjusted R square in the value in the above table will state that 78.4% of variation in the dependent variable is explained by the explanatory or independent variable. So this much of the variation is done or contributed by independent variable in the dependent variable. Okay. Next slide, please. Now, talking about the parametric statistics, which is basically the table from which we will find out whether a particular variable is, contributing or significantly affecting the dependent variable or not. In this case, also, we'll be focusing on the p value. Here are the significance value from which you will identify whether a particular independent variable has an effect on dependent variable or not. Okay. So if this value is less than 0.05, you can say that this particular independent variable is contributing or having an effect on dependent variable, significant effect on dependent variable. So out of these three variables that I have included, these two variables are significantly affecting the ROA or return on asset of a particular bank. Now we have to focus on the beta values because these beta values will define how much effect or how much unit effect it is creating on the dependent variable. Okay. So these are the beta value. Beta value I've already explained that how much variation is brought by the independent variable on the dependent variable. So this can be learned through the beta coefficient. We do not, include unstandardized coefficient because unstandardized coefficients are basically different from standardized coefficients. Standardized coefficient are, you can say, if I'm taking the credit risk, total asset, operational efficiency, the units can be different. So they can generally convert the units on the same part, and then standardized coefficient are used for uh, making the interpretation. So whenever you are, analyzing the regression analysis or regression coefficient, you have to take into consideration these 2 point beta coefficients and the significance value you have to check. Okay. Next slide, please. So this was all about the regression analysis. In regression, before applying the regression analysis, first of all, you have to make sure all the assumptions are fulfilled, whether it is normal distribution of the residual terms, linearity. You have to fulfill all the 6 7 assumptions which are mentioned. Once your assumptions are met, then you have to first and then you have to also focus on the dependent variable, whether your dependent variable is continuous in nature or not. So if their dependent variable is continuous or in ratio scale or interval scale, you can say that you can apply multiple regression. But when we are talking about logistic regression, it can be applied only when your dependent variable is categorical in nature. So dependent variable has to be categorical, and your independent variable can be categorical, it can be ratio, it can be interval. Okay. Next slide, please. Now, talking about the logistic regression estimates the probability of event occurring. Because my dependent variable is in categorical form, so in that case, the probability of event occurring, for example, I take the example of someone who voted and someone who didn't vote. So there are two categories of a particular variable. So we have to assign values to those categories. For example, I'm assigning a value 1, where we 1 means that desired event occurred, otherwise an adverse event occur, the value will be assigned to be 0. Okay, so here in the categorization, whatever category or whatever independent variable you have two categories, you have to assign value 1 and 0 to those values. Now, how the particular logistic regression works? Logistic regression works on the logit transformation or log transformation. So basically, whenever we are running a regression analysis, the dependent variable first have to be converted into log transformation. So the probability, when we are talking about here, in logistic regression, the regression equation will look like this: logit PR is equal to 1 divided by 1 plus exponential raised to power minus PR. Here, when we are talking about this in logit regression, logit PR is the dependent variable and X is the independent variable in a particular equation. So our multiple regression works on least square method, whereas logistic regression mainly works on the maximum likelihood estimation, because here they will be working on the odds ratio. I'm going to discuss about the odds ratio in the next slide. Here, the Lemshaw test is done to test the goodness of the fit. Like in R square, sorry, in like in multiple regression, we test the goodness of fit with the adjusted R square. Here we have the another method. Now, logistic regression, here the concept of odds ratio, which is basically the ratio of probability of occurrence of a specific event to the probability of this case will not occur. So if that I'm going to discuss in the next slide, that what will be the example, what can be the example where you can apply the logistic regression. So how many times the probability that event will occur increases or decreases of if a particular unit is changed in the independent variable. So independent variables effect will be judged whether the probability of event occurring will increase or decrease. So here the equation will be somewhat difficult to understand as compared to the multiple regression. Next slide, please. For example, your main aim, or you want to study, you want to estimate the odds of passing the exam when the students are given coaching. So here, odds of passing the exam, whether the student will pass or they will be failure, when the students are given the coaching, we want to understand the odds of passing the exam. One example more we can consider, that is socio-economic factors determining the debt inclination of the household. If the people have more debt or the people had no debt, we want to understand what are the different socio-economic factors that could affect the debt taking capacity of a household, or whether people take debt or they do not take debt or they do not take loan. We want to understand this concept. Next. Now, the logistic regression results will look like this. I've only taken one dependent variable and one independent variable. We have taken the concept of coaching. Okay. Now, in this particular concept, two things will be different. Wall test, like in multiple regression, the T test was used. Okay. Here, wall test is used. This basically is a kind of beta test, on the basis of which you can say this is the beta coefficient, on the basis of which we can say how much contribution is made by, or you can say whether the significance value is statistically different from 0 or not. Okay, so this is your wall test is like T test. Then we have the exponential value, which is in bracket written B. This is the beta value, on the basis of which we can say how much contribution is made by the independent variable in the dependent variable. And from this, we can say whether it is significant or not. So we can say that coaching is significant because its value is point less than uh, 0.05, and the value is 1.832. Along with that, we have been given here Cox and Snell R square, Nagelkar R square. These are basically the R squares which are calculated in the case of logistic regression. Okay, so these are the two type of R squares which are calculated in the logistic regression, and we can say whether the model is fit or not. Next slide. Now we have to take into consideration the odds ratio. If your beta value is greater than 1, we can say that X stimulates the event to occur, means that your independent variable in the type of contribution independent variable is creating independent variable. This odds ratio show how much probability of 1 in the dependent variable increases when predictor value increases by 1. If your odds ratio is less than 1, you can say that how much contribution or probability of one independent variable decreases when the predictor variable increases by 1 unit. And last is odds ratio is equal to 1, then you can say X does not affect the occurrence of the event. So, on the basis of odds ratio, you have to identify whether odds ratio is greater than 1, whether odds ratio is less than 1, or whether odds ratio is equal to 1. So, if odds ratio is greater than 1, you can say 1 unit increase in predictor increases the dependent variable. If it is less than 1, you will say that 1 unit increase in predicted variable or your independent variable decreases the dependent variable. So this is a kind of regression analysis we do in logistic regression. You have to focus on the variables analysis table. You have to focus on the significance value, exponential value, and on the basis of you will say that how much effect is done by the independent variable on the dependent variable. Can we go to the previous slide? Previous slide. So here we have taken, if we have taken the socio-economic factors, or we are studying the impact of socio-economic factors on determining whether people will take debt or they will not take debt, we have to understand these variables because they are important. They are the independent variables which are creating a kind of effect on their debt inclination of the households. So if I am taking here their, for example, I am taking here the income of the particular household. Income can be categorized in three classification, or I'm taking the socio-economic status. I'm taking wealthy people, middle age, middle income group people, and poor people, and trying to take the, or I'm trying to study the effect of the that particular independent variable over the debt inclination of the household uh, who are included under the study. Then we can be using the logistic regression analysis. Next slide. Next. Next. So, when we are talking about the interpretation of logistic regression, in the previous table, the beta value for coaching was 1.83. So, you can, while writing it in interpretation, you can say, in this example, we can say that odds of student passing the exam who are given coaching is 1.83 times higher than those students who were not given coaching. So the style of writing the interpretation will be like this, where we say that odds of the student passing the exam who are given coaching is 1.83 times higher than those students who were not given coaching. And Cox and Slen square, R square will be the coefficient of determination on the basis of which we'll be judging the coefficient, our goodness of fit. And wall statistics will be like the test, where we will be saying whether your value of beta coefficient is significantly different from 0 or not. Okay. And then we have the value of AUC value, which is generally, if it is greater than zero point 0.5, it indicates the good quality of constructed model. So this is basically the interpretation of logistic regression. The main difference between the multiple regression and logistic regression is just that multiple regression, your dependent variable has to be in continuous in nature. In the logistic regression, your dependent variable can be categorical. Multiple regression works on the least square method, whereas logistic regression, because it works on the probability of happening of an event and not happening on event, it generally works on the log likelihood model. Okay. And the difference could be of the coefficient of determination method. In multiple regression, we have adjusted r square or r square, whereas in logistic regression, we have Cox and Scale r square method, which can be used, and this method is basically based on log likely microhood model. Next slide. Thank you so much. I hope I am able to provide you an overview of all the statistical tools which could be used in research. And as per the research, you can select your appropriate statistical tools. Thank you so much.
Okay, thank you, ma'am, for rekindling us for your informative session about statistical techniques in research. Whatever you have said, it was quite informative for us. Thank you. Now I would like to conclude, to give a pause to my words with a couplet. तू शाही है परवाज है काम तेरा तेरे सामने आसमां और भी है. The limits of the possible can only be defined by going beyond them into the impossible. I would like to invite Dr. Mahinda Punya to come over the dais and just conclude the session.
Thank you, ma'am. Uh, Thank you, ma'am. It's a very nice talk about the statistical technique, and you have to well explained about the parametric, non-parametric tools also, and which we have to select, how we can interpret our data. You have to nicely explain, ma'am. Thank you very much once again.
Thank you so much, sir.
Yes, yes, madam. Okay. And now I request to all the participants that we will meet after the lunch 2:30 to 3:30, and 2:30 to 3:30 our honorable vice chancellor will be conduct the session. So I would request to attend all the participants that its session would be on the implication of the new education policy. Is a very important topics because recently the government of India new education policy is adopted in the higher education and the implication how we can implicate this new education policy. In today's evening session, our vice chancellor, honorable vice chancellor, will be explain everything clearly. So I would request you to attend this the session after lunch. So thank you all of you to participate this session, and thank you once again.